x cubed plus 2y cubed equals 6, and the point is given to us 2 comma negative 1, so 16 on 359. Perfect. Okay, although it's not difficult in this case to find y, we're asked to find dy over dx, and we're not going to solve. In this case, it's not difficult. I'm going to put a dot. You don't have to. I just want to make sure that you understand that this is a function and this is not. This is a function of this. This is the independent. This is the dependent. And we are applying the operator of differentiating both sides. 3x squared plus 6y squared times the inner function prime equals 0. I will solve for this, moving 3x squared to the other side and dividing by 6y squared. So then dy over dx equals negative 3x squared over 6y squared. Yes, I will simplify. Don't write equal symbol here. So dy over dx equals negative x squared over 2y squared. All I have to do now, put a vertical bar when x is 2, when y is negative 1. And just plug them in. Okay, I'm on my page 5. So then dy over dx will be negative 4, 2 times negative 1 squared, which is 1, because squared is changed at the sign, right? It's always positive. So 2 times 1 is 2. So the answer is negative 2. So the rate of change of this function with respect to x at the given point 2 comma negative 1 is negative 2. Any questions on this problem? Okay, moving on then. The rest are all the same. If you want to choose another, please say so. If not, let's choose from here.
I have a question.
Yes.
So, for the problem we just did,
Yes.
when you found the derivative of 2y to the power of 3, it was 6y squared times the inner function prime, but why is that just dy over dx?
Because we should not use this notation. Don't use this notation in implicit differentiation, because if you skip this or you don't see this symbol, right, you're not going to solve correctly. So instead of using y prime, we use this notation.
Okay, so for everyone that has a y, when it says inner function primed, it's basically the y.
Exactly. Yes. So remember, let me refresh your memory how we differentiate a function to power n prime. N f to n minus 1 times the inner function prime. So y to the third prime will be 3y squared times the inner function prime. But not use this notation, but use this notation. So this is 3, this is y to 3 minus 1, which is 2, and this is this. Is that okay?
Yeah, that makes sense.
Excellent. Good, perfect. Other questions here? Great question. With your questions are helping me explain things better. Not just helping yourselves and your colleagues. Okay, excellent. So let's choose another and then look at a word problem. Other preferences?
Let's go with, sorry, was it 20 15. Let's go with 29.
29. Very good. So for 29, let me copy it. Make sure I copy the correct thing. That's P plus 2x equals 40. I would have preferred something also with the product. So just remember, I like to look at product or quotient, whatever. But I like us to also have to practice product. Something like, let's say this has a product. This is just long. It only has one product. Okay, perfect. So, so I should have read. For each demand equation in exercises, right, differentiate implicitly to find dp over dx. Oops, what happened here? I didn't mean to do that. Okay, so this is very important, right? As Landon had a question, he said, why don't you use y prime, basically? So if I use here p prime, I'm not really telling you that p is a function of x. I'm just telling you, find p prime. But if I use this notation, this clearly states this is the function and this is the independent variable. If I don't tell you this, you may consider that this is another function. I don't know. But I'm telling you specifically that this is the function and it depends on x. If I tell you this, I'm not telling you much. If I'm telling you this, I'm telling you a lot. So I differentiate as 2p dp over dx plus dp over dx plus 2 equals 0. I'm after this. It's in two terms. I have to pull out the common factor and move 2 to the other side. So now I know that dp over dx is this over this. With a comma, do not write equal. Every equation has only one equal symbol. Left-hand side equal symbol, right-hand side. So dp over dx is -2 over this. Done. Any questions here? Any questions?
What happened to the 40?
What is the derivative of a constant?
0.
Yes. Is that okay?
Yes.
Other questions here? Okay. So let's take a look and we'll come back to more problems because I want to finish section 3.9 as well. So we can review the entire time on Thursday. So which page am I?
That's a balloon. What changes here? Well, the radius of the balloon, it's this, then it's this, then it's this. So the radius here is smaller and bigger and bigger. What else? Volume. Here's the volume, here's the volume, here's the volume.
More air, more air, more air. What else? Surface area. This is the surface area. Now this is bigger and this is bigger. So these are different characteristics. This one is denoted by r, lowercase r. This one is by volume, this by surface area. If we just look at this relationship, I will remind you that the volume, if assuming this is a sphere, is 4 pi over 3 r cubed. So I found the relationship between these two, like we did before. So what do these depend on? So this is a function, this is a function, this is a function. Why? Because it's not a fixed thing. Right now, at I don't know what time is it. What is it? 7:40. Is this volume? Has the radius is this, and the volume and the surface area. At 7:41, it will be this. At 7:43, will be this. So these three are functions of what? If at 7:40 I have this, at 7:41 I have this, at 7:43 I have this. What are these three functions of? What do they depend on?
So the time.
Of course, they all depend on time. So in other words, dr, if I want to find the rate of change of radius with respect to time, this will be it. If I want to find the rate of change of volume with respect to time, this will be it, because they all depend on time. If I want ds over dt, if I want to differentiate any of these, I have to differentiate them with respect to time. There's nothing else. So now if I have the volume as 4 pi over 3 r cubed, I put a dot under this, because I know it's a function of time. I put a dot under this, because I know it's a function of time. And let's say I want to determine the rate of change of volume. Okay, I apply the operator to both sides. I know that this is a function of time. When I differentiate, I get dv over dt. 3 simplifies with a 3 in the denominator. R to power 2 times the inner function prime. So let's clarify something. This is the equation that connects these two functions. But this is the equation that connects their derivatives or their rates of change. They are related. These two rates of change are related through this equation. These two functions, what did I do? I haven't touched anything. These two functions of time are related through this equation. Their rates of change are related through this equation. Their rates of change are related through this equation. So they are related rates or related derivatives. That's how we deal with related rates. And you can say, I'm sure it's more complicated than you are making it. Yep, it is. So let's go to 364. And let's practice what we just looked at. See what they're asking us to do. See what related rates they want. Okay, so let's start with a numerical example before we look at word problems. What I would like to start with is something like this: 15, 16, 17, 18. Let's start with that, and then decide how to continue with other problems. will anyone choose for us?
18.
18, very good. Let's start with 18. And the 18 is on page 364. Okay, so given y equals pq to the third, find dq over dt when p equals 15, q equals 40, dp over dt equals 55, and dy over dt. Yeah, I copied something else, right? I always do that. I copied half of 18 and half of 17. Wonderful. Okay, so find dp. Okay, I have to start from scratch because I copied something else. I know you said 18. Keep an eye on what I copied. It's not your fault. It's only mine. So let me see. So I'm going to put the cursor here. Okay, so y equals pq to the third. Find dp over dt when p equals 80, q equals 135, dq over dt equals -5, and the last one, dy over dt equals 7,654,500. Awesome. I'm assuming I copied everything correctly. I hope you kept an eye on what I did. So this is all gibberish.
We can't see your screen.
Of course not. I don't know what is going on. I didn't touch anything. Okay, so all this doesn't mean anything other than dp over dt. That means p is a function of t. dq over dt, that means q is a function of t. And dy over dt, that means y is also a function of time. So here we have three functions. They are related through this equation. We have to find an equation that relates dp over dt to dy over dt to dq over dt, and then solve for this. The rest of the numbers have to wait. Okay, so don't even look here. That's all what we needed here. Nothing else. No numbers are required right now. Nothing, nothing, nothing. Just the fact that p is a function of time, y is a function of time, and q is a function of time. We are going to apply our favorite operator in this class. Y prime. Well, it's this. dy over dt equals. Now this is the product. Product. Function 1, function 2. So, p prime, no, dp over dt times the second function plus the first function times the second function prime. 3 multiplied by q to the second power times the inner function prime. They want us dp to determine dp over dt. This is my only variable. This will be simplified, moved to the other side, and I will divide by q cubed, because this is my variable. Nothing else matters. This is all algebra now. So I will move this to the other side. So I have dy over dt minus 3p q squared dq over dt equals q to the third times this. Perfect. So now I will divide this by this because I am after this. This is my variable. So I will divide everything by this, q to the third. And then I plug in those numbers. So dp over dt. Q to the third in the denominator. dy over dt minus 3p q squared dq over dt.